Alrighty, looks like it's just me tonight. Hope I can convince some people to start tuning in because I lecture better with an audience. Kind of strange. A lot of people are the opposite, don't want an audience. Anyways, gonna go ahead and make a console app so I can come in. What lecture are we on anyways? Lecture O. Alrighty. Alrighty. So since I'm getting to do this at home, I actually have Visual Studio 19. So it had a console app creation thing and it filled in all this stuff for me. That's pretty cool. Alrighty, so it looks like we're on. I really thought that we had already gotten to this chapter about loops. Honestly, was really sure we had because we've talked about files, but I don't see that we took the quiz over loops. I don't see. We had to have done this. Let me dig around a little bit more. This is just looking way too familiar. All right, looking at it, I don't see any lectures about chapter 5. I don't see any homework assignment about loops. I do see a homework assignment about files, which is the end of chapter 5. So I'm a little bit confused. I'm going to go ahead. We're going to spend a little bit of time talking about loops. Now, if you've taken a fundamentals of programming class, you already know what loops are. I hope that's the case. However, you may have gotten into here without taking fundamentals, and maybe you've never. Anyways, let's go take a look. That's chapter 5. So what is a loop? A loop is a way to get code to repeat over and over and over. So the easiest loop is the while loop. While this condition is true, do this. Absolutely no, we've done that. So you could have, we could declare a variable, int x is equal to 10. And let's zoom in a little bit more. It'll let me zoom in. There we go. All right. So while x is greater than or equal to 0, how about just greater than 0? And we'll print a message, right? System.out. Wait, that's Java. Sorry. Since I didn't use my boilerplate, things are a little bit messed up. I need to add using namespace std. All right. So now I can just do cout and print out that number, followed by some dots. It'd be really cool if I made it pause for a second, right? So go at 10, 9, 8, 7, like a countdown. Sorry, I'm using a keyboard with a really sensitive touchpad, and so even though I don't mean it to, it moves my cursor around. All right, so, and then we're going to subtract 1 from x each time. So that's a decrement operator, right? Minus minus removes 1 from x. So it's going to count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Since we did not put an ENDL or a \n here, it's going to print it all on the same line. Then what we're going to do here, we're going to put a, cout \n. We have liftoff \n. Right. And since I am running Windows on my Mac, I can actually still use the system pause command. I didn't want to switch over to using Xcode for the Mac because it would look too different. The majority of the class is using Windows. All right, let's run it. So there it goes, right? 1098765431, we have liftoff. See if we can make that text a little bit larger. Okay. All right. I'm just curious how we can make that pause. C++, sleep, a sleep function. That's what I want, is a sleep function. What sleep does is it causes the program to just rest and let other things run for a little while. So if def win32 include windows.h, else include unis.d.h. Alrighty, that would be really annoying to have to do. C++ does not provide a sleep function of its own. However, the operating system specific files provides this functionality. Now, this is completely ignoring the fact that, doesn't have a Mac version. However, since Mac's operating system is an offshoot of Unix, then this would probably work. So I'm actually going to go ahead and do it this way. You could just do this, include windows.h with a capital W, and it would be good to go because you're running on Windows and you know you're running on Windows. Tell you what, let's just make it so that I want you to either do this if you're on Windows, # include less than windows.h, and I'm going to put a comment here. This is for Windows. And then I'm going to comment out the next one, # include, and what was that H file? uni.std.h. So # include uni.std.h for non-Windows, right? Unix, Linux, Mac. The Mac users, let me know if this actually works. You're using Xcode. All right. So bringing that in gives us a sleep command. We can change our loop to sleep so that it'll sleep, a second after every number it prints. So what's the syntax for that? It's just sleep, and you give it a number of seconds. Now, a lot of sleep functions let you specify it in a number of milliseconds. I'm surprised that this one doesn't. I bet if we kept looking, we'd find one that didn't. All right. I saw something else here, which is that they flush the output after printing it and before calling sleep. Wonder why. Nothing wrong with doing that, though. What flush does is it just tells the operating system that, hey, what I just sent to the output buffer is so important. I want to make sure that it gets displayed before I do anything else. So why not? Here, after we print this out, we're going to cout.flush, parentheses and parentheses. Anybody show up yet? Nope, still just me. All righty, no problem. All right, now let's just call sleep, and we're going to sleep for 1 second. Sleep just puts the program into a waiting state. It's underlined it. Identifier sleep is undefined. I wonder why. We've got our # include. Let's run it. This may be an exercise in futility. That did not work. That did not work. Alrighty, Visual Studio, C++ sleep. Let's take a look here. How do you make a program sleep in Windows C++? You include windows.h and you sleep with a capital. Okay, that's a capital S. And this is saying, okay, if you use the Boost library, great. All right, so we'll try it with a capital S. See if that gets us going. That looks very strange to me. Most functions don't begin with uppercase letters, do they? But when we did that, it stopped underlining it in red, so we're good to go. And did it sleep? No, that's because it actually was in milliseconds, despite what that page said. It's just a lesson to us. Don't believe everything you read on the internet. Milliseconds are 1,000th of a second. So 1,000 milliseconds is 1 second. Right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Okay, cool. I'm happy with that. I really am curious if the Mac users can get it to work by doing uni-std. If it doesn't, C++ Xcode Mac sleep, right? We'll find some information about it. How to sleep on C++ and OS X. Stack Overflow has the answer for everything, huh? It's called U-Sleep. I'll add that and make a comment to that effect. Except it's not in milliseconds, it's in microseconds. So for Mac, you would do U-Sleep. 1, 2, 3, 4, 5, 6 zeros. Sleep 1 second for Mac, or for Linux anyways, for Unix and Linux. All right. Okay, so that's a while loop. That was a long time to talk, but yeah, I just wanted to see us playing around with using, some libraries that we haven't used before. It'd be fun to find out what else was in the Windows.h library. There could be a whole heck of a bunch of things. If I highlight the word sleep and I right click and I do go to definition, it'll take me into that header file. And I'm going to see a whole bunch of stuff. Now, this is not really helping me understand it, right? There's just too much in here for me to read, for me to understand. And that's okay. But I could Google it up, and find out what is in the Windows.h file if I wanted to. But I don't want to, so I'm going to close that. All right, so that's a while loop. This is a while loop that counts down from 10 down to 1, right? And then when it hits 0, it exits the loop. Yep, we've done while loops. How about a for loop? For int y is equal to 0, y is less than or equal to 100, and increase y by 10 each time. Y plus equals 10. Right? System.out.println. How about just print out that number, right? Why am I doing Java commands? I'm sorry, gang. I just taught 3 hours of Java today. C out less than y, less than endl. Let's flush it so that we can call the sleep command on this. We have a new toy, cout.flush. Send everything to the screen, make absolutely sure it's out there. Now sleep. Let's not sleep as long. Let's only sleep half a second. We're kind of impatient. And you know to change it into U-Sleep if need be. Right? 10987, this is going to get a little tedious watching it over and over and over. I might set it to 5 so that it only counts down from 5 to 1 rather than 10 to 1. Right? And now it's only sleeping half a second. I like that better. Why don't we set our counter, though, to start, rather than starting at 10, we're going to set our counter to start, 4, 3, 4. Yeah, that's good enough. Okay, so that's a for loop. You initialize your structure, you initialize your loop control variable. Y is my loop control variable. So the syntax of a for loop is for, and then you have your initial condition, right? And then you have your test condition. So you have your initializer there, you have your test, and then you have your update. And then you have your body of your code after that, right? And that's nice because all three things are in one place. Otherwise, this is our init, right? This is our test, and this is our update. And I could put init LPC for loop control variable. You know, the more comments I add, in a way, the harder it is going to be to read. Loop control variable. Test the LPC and update the LPC. Isn't it nice to have all three of those things in one place? Now, when I'm updating the loop control variable at the end or in a loop, I would prefer for it to be the last thing, just so that it's easy to spot. Right now it's hidden, you know, in the middle of our body of code. I would rather cut that and paste it here. And by the way, I just saw an interesting little thing that it offered to let me do. When I highlighted it, it said view code. What does that do? View code. Doesn't do anything. Alrighty. Well, I'm going to leave that alone. I'm not sure what it's doing. Okay. So that's a for loop. Got a start condition, an end condition, and it's an update. What if we want to count up? That was counting down. Let's just count up by ones. Let's count from 30 to 40 by ones, right? So int start is equal to 30. Int stop is equal to 40. For parentheses, int y is equal to start, semicolon. Keep going while y is less than or equal to stop, semicolon. Y plus plus. Let's print out y. Followed by a tab, just to be different. Let's flush it. So cout.flush. I really don't think that's necessary. I think we could delete all those and it would work just as well. And then sleep for half a second. And then when it's done, we're going to cout an end of line. But that has to be outside the loop, right? Because we want to print all of this in a horizontal line and then go to the next line. All right, now if we go 30 to 40 with tabs in it, it's going to go off the screen. So why don't we just make it go from 30 to 35? I think that'll look okay. I have a little control bar up here that you probably can't see, but Zoom keeps popping open a control bar and it keeps hiding my green run button. There we go. Right? All right, now it's doing its thing. Hello world. 4, 3, 2. Oh, and I managed to make it stop by accidentally clicking on the window itself. Okay, 4, 3, 2, 1, 0. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? Now it's counting 30, 31, 32, 33, 34, 35. All right. And we have liftoff. Now, really, I wanted that we have liftoff button right, message right here. So I'm going to go and cut that and paste that into its right place. Sorry, I'm not used to running Windows on my Mac. I haven't figured out where all the windows are yet. So anyways, I want we have liftoff to be, cut that, and paste it right under our very first loop. Just like that. Something's looking a little bit odd. These things aren't lining up on the dotted lines. I haven't tabbed them over correctly, or I did something wrong. See if I can fix that. Okay. So those are for loops and those are while loops. For loops and while loops are known as pretest loops because the test happens up at the top. That's a test, right? Does the test right here. And if the test was false, it wouldn't go in here at all. What do I mean if the test was false? What if y started at 100, right? Keep going while y is less than or equal to stop. Well, is 100 less than stop? Is 100 less than 35? No, it is not. So that would not work. It would not print out any of this stuff because it's a pretest. So while and for are pretest loops, meaning that if the condition is false, the loop body won't even be executed one time. Then there are post-test loops, the do loop, meaning that the body is executed at least once no matter what. All right, let's do that. Let's make ourselves a new variable, int, and let's make it a double. Double d is equal to 0.000 semicolon. Now do this. Do curly brace, cout d equals, in quote, listen, d, listen, endl. And let's add something to it, right? Cout, come on, type. Cout left, wait. We're just going to add something to it. D plus equals 0.05. Right? And we're going to keep doing this after our closing curly brace. We're going to keep doing that while d is less than or equal to 0.5. So what that's going to do, it's going to print out 0, and then it's going to print out 0.5, 0.10, 0.15, 0.20, and so on until it exits from here. When d is no longer less than or equal to 0.5, it will exit the loop. Now I didn't put a sleep in there, so it's going to do a lickety-split once it gets there. There we go, right? From 0 to 0.5. Now, if we were clever, we could get this to show a rounding error. We've done that before, right? By adding things in that did not round off evenly at floating, according to the floating point. I don't know why I used float. If I did, no, I did not. I used double. Pat myself on the back. This is a post-test loop, meaning that even if d started off larger than 0.5, it would still print it at least once, right? So the number 100 is definitely larger than 0.5, but it's going to go ahead and print it anyways because there's no condition, right? There's no pre-test condition, so instead it does the body, and then it checks the while loop, and since the while loop condition is false, then it exits and goes on its merry way. So we will see it print one thing. Now these sleeps are getting real tedious, aren't they? There we go, right? It did print out 100 because it was a post-test loop. I'm going to change that back to 0. All righty. I think that's about enough about loops, really. And there's some stuff we could do more about loops. We probably ought to demonstrate the break statement and the continue statement. So how about this? For int z equals 0, keep running while z is less than or equal to 10. Every time we go up, we want to increment by 1, so z plus plus. Let's cout z, but what we're going to do is we're going to check to see if z is equal to 5. We hate 5 so much, we don't want it to print anything out. So if z is equal to 5, in parentheses, continue. What does that mean? Continue just forces a re-triggering of the loop. Comes back up here, executes the loop again. So when z is equal to 5, it's not going to get to this statement. It's just going to jump back up here, add 1 to it. Z is going to equal 6, and then it'll be able to get down here and print it out. So this is going to print from 0 to 10. All right, these sleeps are really getting to be a little bit too much for me. I'm just going to do a search and replace and change all of the 500s to like 100, something like that. So I'm just highlighting them, and I'm going to hit Control H. Whoops, that didn't work. That just closed the window. Edit. Okay, this is taking longer than it would have. I saw it though. Edit, find, and replace. It was Control H, but my Mac keyboard interpreted it differently. I'm going to lower that to 100. Replace them all. Okay. Go for it. Run it. All right. Now the 1000 at the beginning is still going, so it's still doing that as a second. Okay, there we go. That's much better. All right, so it printed out 0, 1, 2, 3, 4, but it skipped 5. It skipped 5 because our continue statement, right? If z is equal to 5, continue, which means retrigger the loop immediately, jump back up to the top, increment the counter again, and then keep going. Then there's the break statement. We certainly have seen break before. What if we did not want to stop at 10? What if we wanted to stop somewhere else? So if z is equal to 8, break. That's just going to kill the loop at that point, right? So it's not going to print out 8. The highest number it's going to print out is 7, because if it gets down here and it's 8, break means jump out of the loop. So this goes back to the top of the loop. And this exits the loop. And so as predicted, it did not reach 8. It stopped at 7. So that's break and continue. Now we're going to do a nested loop. What's a nested loop? It's a loop inside of a loop. Let's make something that'll print out a rectangle of a certain number of rows and a certain number of columns. So we could ask the user how many rows and how many columns. So int rows, comma, COLS. Let's ask them, cout how many rows, question mark, space, space, greater than, end quote, semicolon, CIN greater rows. Now let's ask them how many columns. Man, I hate new keyboards. All right. Cout less than, how many calls, question mark, space, space, end quote, or greater than, end quote, semicolon, CIN greater than calls. Now let's have a nested loop. So for parentheses, int r is equal to 0, semicolon, r is less than rows, right? So it's going to go 0, 1, 2, 3, 4. Like if they say 5, it's going to go 0, 1, 2, 3, 4. Or we could start it off at 1 and go up to less than or equal to the number of rows. That does the same thing, right? Just starts the counter at 1 past. All right, and each time we want to increment the counter by 1. Curly brace. Let's do the columns. For int c is equal to 0, 1. Keep going while c is less than or equal to calls. C++. Now let's print out an asterisk. Cout less than, quote, asterisk, end quote. Now I'm not printing out an ENDL because I wanted to print out an entire row, right? If we say I want 20 columns, I wanted to print out 20 asterisks in a row. And then once it's done with the for loop, then it's okay to print out an end of line, ENDL. All right, let's run it. All right, how many rows? I want 10 rows. How many columns? I want 5 columns. And there we go, right? So we did a nested loop. One more nested loop example. Let's print like one You know what? I think that's actually enough, unless we did a multiplication table. And I think we've done multiplication tables before. So I'm pretty sure we've actually done this. All right, let's stop there. I think that we have covered actually a majority of the chapter, right? And yeah, there's a little bit more you could do with it. You can use a counter. The counter is a variable that's incremented or decremented each time a loop repeats. That's our loop control variable, right? The do while loop, we certainly talked about that. The for loop, we absolutely talked about that. If you want to, you can do more than one thing in the introduction to the for loop, just like that. Right, in the initial stage, you could set two different variables if you wanted to. Or you could leave out the initialization entirely. Keeping a running total is when you keep asking, or you create a sum variable up at the top of your loop, and then you keep adding to it. So say that we wanted to add up all the numbers between 1 and 10, classic summation. Let's declare a sum variable and set it to 0, and let's write a for loop that'll count from 1 to 10. 4 parentheses, int y is equal to, why am I keep doing y rather than x like I normally do? Because I did use a variable x right here. Now in this language, I could get away with creating a new variable called x inside my for loop, but I try to avoid reusing variable names in that fashion. So I'm just going to use y again. Y is equal to 0, semicolon, keep going. Well, now let's start it at 1, and we're going to go up to the max. Let's declare a variable that's the max, right? So int sum max is equal to 10. We're going to add up the numbers between 1 and 10. And we did it numbers between 1 and 1,000. So keep going while y is less than or equal to sum underscore max, semicolon. And each time add 1 to y. So sum plus equals y. Now we can get down here and say the summation of, end quote, less than sum underscore max, less than quote, space, is, space, end quote, less than sum, less than NDL. Seems like I've lost my pause. When did that happen? I think I accidentally deleted it. Apparently I did. All right, I'm going to add it back. There we go. System parentheses quote pause. And yeah, it's going to do all its business. How many rows? 10. How many columns? 20. There it goes. And the summation of 1,000 is that, right? How large could we get? Let's do the summation of 1,000,000. See how long it takes to calculate that. So I'm going to set our max is 1 followed by 6 zeros. There we go. No accident. That's actually 7 zeros. Let's make it 6. Is it going to take any time at all? These things, computers run remarkably fast, really. As long as you're not printing things. If you're printing things, that's what slows them down. 5 rows, 5 calls. Right. Look how fast it figured out. Look how fast it looped 1,000,000 times in order to calculate that. Computers sure are fast. Make it 1,000,000,000. Just out of curiosity. I'm going to add 3 more zeros to it. That might actually take some fair amount of time. Let's find out. Okay, that's taking a fair amount of time, but it didn't take that long, right? There we go. That's the summation. A 5 followed by 17 zeros is a summation of 1 billion. Okay, so we've talked about creating a tally, a running tally. That's what this is, except in this case, it was a running tally of a sequence of numbers from 1 to a billion. We could also ask the user for the values, right? Like enter test score number. So like, let's create a variable called the number of tests. We're going to ask for 5 test scores. And let's create a variable that's the sum of all the tests, right? So double sum of tests is equal to 0. And let's just do while, let's create our test variable. Our loop control variable is just going to be called, I don't know, num, like test number. So while num is less than or equal to the num underscore tests, less than, cout less than, enter test score number, end quote, less than, num, semicolon. Let's also add a space to it, right? So it'll look pretty. A colon, right? There, that'll be pretty. And we'll let them type it in. We need a variable to store it in, right? So int score, or let's make it a double, right? So double score, and then CIN into score. And then add one to our test number, right? Num plus plus. And yes, we could have written this as a for loop as well. I just felt like getting creative and write as a while loop. So we initialize our loop control variable there. We test it here, and we update it there. And now we can calculate the sum and the average, right? The average is equal to the sum of the tests. Oh, I never added the value to the tests. So the sum of the tests divided by the num underscore tests. That's the average. But I never incremented sum tests. We typed in the score, but we never added it. So sum underscore tests is equal, or plus equals the score that they just typed in. And then we could print out the average, right? Print out the sum too if we wanted to. Cout average score is space end quote average less than India. All right, so this is a running tally. Another example of a running tally. We initialize our tally variable here. We ask for a value and we update it. We add it to our tally. Four rows, 4 calls. Now what's it doing? There it goes. It added a billion numbers. Test score 1, I made 100. Test score 2, I made a 90. Test score 3, I made a 93. Test score 4, ran into trouble, I made a 50. Test score 5, I got it back into shape and made 100. And the average is 86.6. All righty. I think we're good there. We do need a little bit of homework there based on this idea. So what I'm going to do is I'm just going to tell you what kind of output I want. Using a for loop, write code that will print these numbers. 10, 15, 20, 25. Oh, come on. 30. Right? Then using a while loop, write code that will print these numbers. And I see that my PR disappeared on the keyboard. Why are you hopping up and down over here? Go away. All right. Print 29, 28, 27, 26, 25. I must be hitting some key that's trying to load the Visual Studio documentation, because that's what's popping up here. All right, so using a for loop, write code that will print these numbers. Using a while loop, write code to print these numbers. Really, that'll prove the point. I can think of one more loop that I didn't cover, which is the while true loop, which is where you ask them to enter values and you let them enter a negative value in order to quit. Right, -1 to stop, that kind of thing. I think we've gone far enough here. Let's go ahead and stop here.